Today we are going to talk about Angular. How many of you have done Angular before? Most of you, cool. So my name is Bartosz Pietrucha. I've been for a while at the very beginning of my career Java developer. Then a couple of years ago I started working with JavaScript and totally fell into it, and currently mostly focusing on front-end side with Angular. I've been doing enterprise software, crafting enterprise software for over 5 years, and I have a master's degree in computer science in software engineering field. And the thing that I mostly focus on recently when it comes to my career is Angular Academy, which is consulting and training company for people who want to master and go on the higher level or the next level with Angular development. So today we are going to talk about scalable architecture. So why the Angular is crossed out? Because the concepts are going to be more general. I would be using Angular as an implementation example for scalability in front-end, but you might be able to apply them in different solutions like maybe React, maybe also Vue, but as I'm Angular guy, I would be using Angular as fundamentals. By the way, you can follow me on Twitter. I would be uploading the slides after this presentation, so if you want to go back and study on your own, just be sure to check the Twitter. So what is the software architecture? Let's stop for a while. Let's think about software architecture. So let's start with some gurus in our industry. So Martin Fowler says it's the highest level breakdown of the system into its parts. Or other definition might be saying that these are the decisions that are hard to change when we develop the software. I like to say that the architecture is somehow the composition into parts or those pieces or the components of like a huge system, and the restrictions, the rules, the ideas, how they communicate, what are the rules of communications between those parts, how they talk to each other, and form a bigger system that solves some kind of problem, some kind of task. So next, let's try to answer. Before we jump into our topic, we are building some foundations. What or how front-end applications scale. Because when we think about scalability, most people think about back-end, and we need more computing power, we need more servers. So basically, we can scale up or scale vertically or horizontally. But the case of front-end is specific, because the scalability also is important there. So we can think about growing complexity. We start our application, which is very small, but sooner or later, when we build a huge enterprise application, the complexity would grow, and we will have more and more requirements. We would need to somehow be able to tackle them easily. The amount of data that we need to manage is growing, and then it could actually hit our performance. Then we could experience so-called performance degradation. Another thing that is also important that we might want to consider is how do we manage our growing team? We start small, then we have like a huge international distributed team, and we need to also be able to manage it efficiently. Also the rotation, right? Some people come and join, some people leave and come, and we would like to allow those new developers get up to speed as fast as possible. From the day one, we want to make them productive. We don't want to have a huge or long onboarding period that is lasting weeks or months for them to start being efficient. So basically, this what I understand, and I believe most of you experienced and can actually resonate on that, what it means that we are building huge and scalable front-end application. Anybody can think of this image for a while and have experienced this, some kind of situation? Because early development is fast and easy, right? When the code base is small, we understand everything. We just, easy peasy, I will just add this. Hello. I would just add this new feature, and it will be very easy. But as the time goes on, we are adding new features, new people are coming. Our speed of development would be decreasing. And if we look at this diagram, this is not, once again, I was always mentioning during my talks, this is not a scientific research. This is just my gut feeling. This is what I experienced throughout my career, that at the very beginning, if you are not investing in the architecture, just doing the business development, you are going faster than as if you would be building your foundations. But later on, as you go, because this horizontal axis would be the time, and as you go, things start to be complicated. I don't understand this piece of code. I don't understand what this developer meant to actually implement here. So because of you haven't invested at the very beginning because you wanted to go fast in the foundations, you were faster, but later it will echo in some form of technical debt. So our goal, we have like 3 sub-goals. We want to achieve sustainable development speed and to have an ease of adding new features. And of course, we would like to care about our performance when it comes to our application physically being able to respond to user requests and load the data and so on and so forth. So this is the plan for today's talk. It's going to be touching 3 different areas in the form of complexity, reasoning, and performance. And I'm going to give you some 5 areas, tips, maybe advices. It's not any golden solution. It's kind of like, you should treat it as some recommendation, maybe, some ideas that you may try to think about, but it's not like 100% golden solution. I'm going to talk about those 5 pieces of advice. But before we jump into, maybe let's also try to describe some underlying technology, some underlying terms that I would be using. So how many of you have been using RxJS? Half, maybe half. So RxJS is an implementation of reactive extensions that allows us to program in some different paradigm, which is called functional reactive programming. And to understand FRP in the short form, we need to understand what the stream or observable is. And if you look at this diagram, and this first, I don't know, tail maybe, or this first part, this first rectangle, represents a single value that is available now. And it is a simple variable, right? But if we move in this dimension to the right, and we want to think about synchronous or available values in the multiple way, that we have multiple values, we know that there is some type which is called array. But as we are dealing mostly with asynchronous requests, we need to somehow represent the value that would be available in the future as a result of some asynchronous operation, for example, HTTP request. And then we can have a promise. The promise would be resolved in the future as a result of some action that we are waiting for. But the promise gives us a single value. What if we want to have multiple values over time? We are streaming some values, or we don't know how many values would come back from the place which we are listening to. And this is called observable. Observable is a fundamental aspect or the fundamental piece of functional reactive programming, and RxJS is a library that allows us to build in this way. So how do we implement observable? The idea is very simple. We have 2 actors, let's say, observable and an observer. And we just implement a very similar interface as if we would be implementing a listener. We just say that the guy who we are observing, which is called observable, would emit a values in the form of next, error, or complete, telling us about future values. They may come, they may not come, and we don't know when and how many of those values would come. Let's think about the other example. Let's think about an event. Events are everywhere in the front-end app. And let's think about such a native event like key up. And this is the perfect example that we can model an observable. Why? Because we don't know when the user would click. We don't know how many times the user would click because he can click whenever he wants and how many times he wants. So what we are doing, we are building a stream, a observable from that event, and the benefit of this modeling in this way is that we can use operators that allow us to somehow manipulate this stream. So let's think for a while what this code does. First of all, we are using a map operator. We are taking out some particular property from this event, and then we use the bounce time, which would wait every 400 milliseconds, so that we don't want to capture every single click. And then we would like to distinct until change, which means whenever a user clicks the same exact button, we don't want to capture this value. And only then we would like to so-called subscribe, which is somehow listening to this event. What it means that those operators allows us to do kind of sophisticated things without any side effects and without any imperative code, which means it's easier to reason about this code. It's easier to implement things that would be hard to implement in this imperative way, because we would need to introduce some state, calculate some time, compare some values, and here we are being given tools, which are those operators that allows us to treat our propagation of change in this observable way. And there are a bunch of operators that cover a lot of cases, and the only thing you need to do is to compose your operators to achieve your goal. And then another piece of fundamentals that we want to introduce comes from Redux pattern. How many of you has played with Redux? Most of you. So I will not be focusing on this that much. We know that we have state, which are all the values in our application. We have the view, which represents the states over the screen. We have the store, which is like immutable structure of all that we would like to store in the store. Wow. So this is kind of all the values that are somehow persisted in this form of data structure. Action is something that we would like to, let's say, dispatch, that represents what has happened. And the reducer is this pure function that would, having the actual state and the new action, produce the new state that represents the result of some user interaction or maybe HTTP call request or whatever might have caused a change in our system. Okay. So how does it look visually? We have our in Redux, which can be actually applied to any component-based architecture. Looks like we have a bunch of components that form a tree. And imagine that we have loaded list of users or the name of logged user somewhere in our application in the components visualized, and they live in a single place. There is only one source of truth, which is immutable, and there's only one copy which we refer to as a source of truth, which allows us to maintain consistency, because we could make up in the situation when here and here we would display the number of followers. And if we increase the number of followers, we would need to remember that it's displayed here, displayed here. Having Redux and store prevents us from this situation when we have inconsistency, because we only have to update a single place in our application. And then somehow other places would listen in the form of observable when we would think about Angular and GRX. I'll go back. And what is the flow? Again, it's kind of recap of what we know from Redux, that we have a component, and the user may interact with this component with, I don't know, a mouse, or use of the click of the button, or whatever other user interaction might happen, and then it would dispatch an action saying, increase number of followers. And this is the end of the component's responsibility, just to dispatch an action. And there is some kind of reducer which implements this function. Okay, if there was an action called increase number of followers, I should take the actual number of followers, increase it with a given number, and update the store, and then this state would be projected to any component that would be interested in displaying it. So the component is just the UR part, the part that takes some data and displays it in the given place in our application. So I believe this was kind of like a 101 for the fundamental terms that we want to introduce. We want to delve into our architectural or maybe high-level tips or recommendations. First one, which I find most interesting and most important, is how do you actually divide your application into abstraction layers? How do you think about this high-level separation in your application? Whoa, too much. So let's look at this diagram. Let's think about our application as a cake. We would like to have some layers. And from the top, or maybe from the bottom, let's start with the visual part. We would have so-called presentation layer. And there we would have those presentational modules which will have the components. All our UR parts, it would be like container components or like dump components. We'll later discuss this kind of pattern. And these guys would be only displaying the data and taking in user interaction. And on the top of that, in the middle part, we have so-called abstraction facade or abstraction layer, which would be our middle tier between our business layer or core layer, where all our business logic would live, how to manipulate the data, how to validate the data, later we would understand. But presentation layer would be something that only presents and delegates. So we are thinking about the separation of concern or maybe single responsibility of particular parts of our application on the high level. So this part of the application would be responsible for displaying UI, as I said, and handling user interactions. It does not know how things might happen, but it only would delegate this responsibility through abstraction layer to our core layer that would implement our business logic. Of course, this is the horizontal way we would like to divide our app, and then those guys would also be divided into vertical modules. Angular has its own system of modules, but module is something abstract that we can implement, and we will divide our application vertically into, let's say, features. Other thing is that those components does not know anything about the state. The only state they can have is the private local state. For example, because when we think about the state and the store, this is the case usually something that we would like to share with other modules or other parts with the application. But if we have some very detailed local state, which we don't consider an, let's say, business or application level state, but only UI state, let's say, think about the side nav, which is open or closed. We probably maybe not want to expose it to outside world. That's why this part of state might be called local UI state that would be private to this component or private to this module, because this is the only place we care about it, if the navbar is collapsed or not. We don't need to share this state. And then we have this abstraction layer. It is really cool to divide your core layer and presentation layer with these abstraction layers. It will give us a nice layer of decoupling, and it will mediate the communication. We will learn later what it means and what benefits it gives us, but the responsibility of this part would be only to expose the particular streams of state, because if we would give our components an access to the store, we are allowing to see all application state. In this case, we are saying that for this module, for these admins or user modules, I would like to select only these parts of state and give the streams of the state to these components. And this is something that those modules or those components would care about. I would not show them the whole world. I would encapsulate the parts of the state. And also, I would give those components API to manipulate the state. That's why I'm able to, let's say, isolate from the given implementation of the store. If I'm using NGRX or Redux, or maybe I'm using Firebase, because that's the thing. I'm isolating the components from the given store or state management I'm using in my application. They would be completely separate because of this facade or abstraction layer. Because someday I would maybe made a decision, I don't need a store anymore, I would like to move to Firebase. Or maybe I have not been using state for day one, I was using only behavior subjects that model the state in a slightly different way, but achieving the same goal. And finally, we have our core layer, which has all our core application logic, which is data manipulation, communication with outside world, and it has this core module, which has all important modules, all the providers and services, and the root component, and contains maybe modularization, configs, utilities. So basically, we have seen how we can divide our application into layers. Now, important aspect is how do we care about all of our aspects when it comes to complexity, performance, and reasoning. Unidirectional data flow, how we can visualize it and how we can achieve it in our web app. When it comes to Angular, this part on the bottom, this container and presentational modules, components communicate in that fashion by default, by design. We can only put the data down from the higher level component to the lower level component with the input, and then we can only communicate with the component which is in the higher hierarchy level with the output, with the event. So basically, this is the components level flow. The data can flow only this way. So back then, when we had AngularJS, we have not have this, let's say, restriction. We could actually put the data back and forth with no restriction. We had these watchers, and everything could finally come even to the loop. Because here, whenever data flows into only one direction, we have those data binding. And if there's data here that was bound to some lower level component, and then if it was bound up again, we might have a loop. In this case, data can only flow in one direction. This is the restriction that we need to follow when we build Angular application, and it actually have very important, let's say, consequences, because it allows us this performance stabilization. Because in this case, I need to only go from the root to the top to stabilize my state that is reflected in the components. This is so-called change detection process that Angular does every time it needs to ensure the stability of the system. What I mean by that is that think of the variable bound somewhere in the component, and it's going to be changed in some JavaScript module, and what change detection in Angular does, it has to ensure that every time we bound this value to the view, it has to actually represent the actual value. So we only need to go from the top to bottom, and we are done with the process of stabilizing the state of the application. So this is the components level flow. But on the application level, we also have the possibility to follow the same rules. And we can use Redux, right? So again, all the actions can go up via action dispatching, and every value that is modeled in the store can be reflected back to the application via observable. So again, this is application level unidirectional data flow. Let's go into a little bit more detailed approach. Just give me some mate, please. Okay, so we have an example of this flow. Very simple application that is composed of 3 components. First component is this container component that contains 2 child components, which is a list component, this is the list component, and the details component. And the outer component is our container. So, getting back to our example of abstraction layers, it made 5 minutes left? No way. Okay, we need to go faster. Because I have a bunch of ideas to also describe. So, let's gear up. We have the components, and then they would communicate towards the core layer via the facade, and whenever they want to call an API or update the local state, they would have all the machinery up there in the core layer. And then if we want to reflect the state change, we have this dashed line that represents the stream of the state, which is in form of observable. Boom. So how would it be? Imagine that our facade exposes promote employee function, and then we would like to update the API, and then when we think that it was succeeded, then we update our local state via store, and then we reflect this with our stream of state. Boom. And other reason why we have this facade is this way we would maintain the client state and the local state. Imagine that we would like to use approach which is called pessimistic update. You see that I'm calling the API first, and whenever I see that it succeeds, I would update my local state, and only if there was an error, I would call some error handling logic. So first of all, I'm calling pessimistically server to ensure that the update succeeds, and only when I have the confirmation, I would update my local state. This is different approach from optimistic update, because here I'm saying, okay, I would optimistically update UI, and then only if I see there was an error, I would roll it back, right? So I optimistically update the UI. And the facade is a perfect place to implement this, because this is not some kind of application business logic, or maybe UI component responsibility. This abstraction, which mediates between my business and my UI, is a perfect place to maintain this synchronization. Okay, 2 last pieces. Maybe 4 minutes would be good time to present it. Predictable state management. We have already touched this aspect, that we want to have a single place where all our data that are actually subject of change would live, which is called store, and every change would be then propagated to subscribers, maybe components that would know what data they would like to display in the component via subscription on observable. We have learned what observable is. It allows us to propagate change over time, and every module introduces its own slice of state. An implementation of this Redux pattern in Angular is mostly known one NGRX store. How do we want to, if we have this division into vertical modules, and then we would like to say, okay, we have the UI module, or the application module, feature module, employee, and I don't know, settings module or user module, and whenever we want to communicate with different module state, we would abstract it away again from our UI part and let the facade take care of it. We don't want our components to know that there is some different place in the application state that they need to communicate. They just know via the facade what they need to call. And the last, not two last, smart and dumb components. Think about that we have 2 kinds of components in the application. Those smart ones that would communicate with our facade, and they would react to the events and use dependency injection to communicate with the facade, and these are usually top-level rootable components. They know actually how to communicate with this facade. And those dumb components are only special cases of like special button, special list items, special spinner that are so-called dump components, because they only have inputs and outputs. They would not know how to communicate with the facade. They would only emit an event in case of user interaction and would take as an input the value that they display. That's it. They only present. And having those division into those kind of components gives us a way to better reason about how we composed our application in components. This is again the presentation. Our smart component would be this employee container, and this list and item would be dump that only take the data inputs from the container that takes them from the facade. And again, how do we bind this? Via inputs and outputs in Angular, that whenever container has the data, it would bind this via input, and the single list item would be bound to the item via input mechanism, and output mechanism are those events that are emitted by this component to the container that would take care when it comes to a business function that has to be undertaken. And the last part is modularization and lazy loading. As I said, we had this horizontal and vertical division that we would like to decompose our application to actually scale. And another approach, another benefit in Angular for using modularization is, one more thing, this is the example of directory structure that I find very useful. I would like to put all the things that I presented in this kind of folder structure that allows me to very easily navigate around my module structure in a physical way. And lazy loading is that whenever we have a huge application, we initially want to show the module that is like the very first one that the user would interact with. And this is the moment when the application is loaded and bootstrapped and, let's say, available for the user to manipulate and work with. And whenever he accesses the module, which is, let's say, used in the secondary turn, we lazy load this module. How to achieve it in Angular? It's very simple. We just need to come up with the proper configuration, and we are done. Angular router would take care of lazy loading. The only thing we need to do is to use load children here property that would point to the particular module that we want to physically download from the server in the lazy manner, not upfront, because the bigger the package or the bigger the bundle is, the longer it takes to initially run application, because on the wire it would take longer to take this data, especially in the low-end devices when we have like mobile phones. It's very highly recommended to split this into modules and to lazy load them to let the user this initial interaction available, to let it actually load faster for the end user with low-end device, because other parts would be lazy loaded. Yeah, another example of this is the routes for lazy loaded, and then whenever we have this lazy loaded module, this is the main configuration. We are running out of time. So again, the last idea is the preloading. So imagine that you are loading the very first module, and in the background, you want to tell the router to preload this module so that whenever we finally want to open this module, it will be already there. The only thing we need to do in Angular is to provide a preloading strategy. I encourage you to study this slide later on, because I think that the bunny is going to kill me. So thank you very much. In order to follow me, you can look at Twitter and my website. And other two links that I wanted to share with you is that recently I also opened the Slack channel for Angular Academy followers that I help with the problems that the community is facing, and also the show, which is like a webcast with fellow people from the community, which we discuss together on the webcast form. You can follow this channel on YouTube, and also I encourage you to join the Slack to have a discussion, maybe about the topics here. I would love to chat with you guys to see what problems do you have and also try to answer your questions. Thank you very much.